Assalamualaikum. Today I will present about project of additive manufacturing. So the project title is Multifunctional chopping board. Before I will go through, I will introduce myself. My name is Arni Nabila binti Muhammad Zainuddin. My group members is Sashi Varma, anak lelaki guna sekarat, Nur Nabiha Naja binti Mustafa Kamil, and Nur Syafadina binti Azizul. I will start the presentation with the introduction. The introduction of this project is, as technology progresses, people have a relatively high need for food. A chopping board is an essential piece of kitchen equipment for cooking tasty dishes. Accordingly to the project title, a multifunctional chopping board was created that not only slicing food but also protects the kitchen surface or table from scratches. ABS plastic is the material utilized. The aim for this project is to provide students the opportunity to use Autodesk Fusion 360 to create a model with complex 3D geometry. Students must also understand additive manufacturing technologies and materials as well as be able to synthesize their economic and environmental impact on the manufacturing value chains. So the objective of this project is to identify and redesign new features in terms of part consideration on existing product that is only suitable for additive manufacturing. Second, to analyze redesign by implement reverse engineering and fabricate product using Autodesk Fusion 360 and additive manufacturing method. Third, to develop the economic analysis using bill of material, which is BOM. And lastly, to determine the method and process using knowledge on additive manufacturing.
A great day to my doctor and my dear friends. So today I'd like to talk about a literature review as my part. My name is Shashi Varmanaki Gurasekaran. My metric number is B05 18 Basically, my project is on multifunctional chopping board. So previously it was a traditional chopping board. So we have given task to redesign the chopping board by using the reverse engineering knowledge from additive manufacturing and also the use of Fusion 360 in such way of form modeling. So the technique chosen to manufacture this multifunctional chopping board is fuse deposition modeling. So there are several other techniques introduced, but based on the previous researchers, I choose this FDM modeling. So this because material feedstock for FDM is basically on ABS and also PLA. These two are the most common material used in FDM. And also the build orientation, the staircase effect is affected by layer thickness and varies depending on the surface and component orientation. There are many other factors that involving in FDM, basically the build time and also the machining parameters and so on. So here is the material selection for our project, which is the ABS. And also this table is to make comparison between PLA and also ABS, and these both materials are commonly used in fuse deposition modeling. So for the first one is the tensile strength, which is ABS have 27 MPa and also PLA has 37 MPa. For the elongation, 3.5 to 5% for ABS and 6% for PLA. The flexural modulus and also the density, and we can see the common products here. For the ABS is written as Lego bricks and also the electronic components housing, and also the PLA for the cups, plastic bags and also cutlery. So figure above shows the safety helmet, which is produced by ABS material, and also these stuffs like a cup, uh, these produced by the PLA material. As for our project, Fusion 360 plays an important key role for our project because it is very useful for our designing of our CAD model and also redesign, which is reverse engineering, to a traditional chopper board to the multifunctional chopping board. So these are the free form techniques that involved in Fusion 360. So the modeling strategies is edge modeling and also box modeling. This is the common type of modeling that I gained from several publications. So there are other types of modeling also. So basically for the edge modeling, it will extrude the edges, and also for the box modeling, it will extrude the faces. So these are the pros and cons of edge and box modeling. So edge modeling is easy, but it consumes time, a lot of time. But for the box modeling, is more difficult, but less time is taken to complete. So here is the figure shows the box modeling and also the edge modeling. You can see the differences. So for the edge modeling, it will extrude in the edges, and for the box modeling, it will extrude in the faces. So here,
Assalamualaikum and good day. I'm Nuna Bihanaja and I will explain about the methodology in our project. Product that has been selected in this project is a chopper board. As we all know, chopper board has been used since a long time ago and it widely used in the market. The function of this product is to cut the food. Besides, the old chopping board have a simple design and have one function only. Moreover, it did not have a special compartment to place the food that has been cut and a special place to put the cutting equipment. Lastly, it have they have a lack of safety since it doesn't have a specific place to put the cutting equipment, and less hygiene since the food that has been cut will be exposed. So we have come out with a new design which is multifunction chopper board. This new design is an extension or reverse engineering from the old design. This product offers many advantages to the consumer compared to the original product. Moreover, this new product comes with a compartment that makes it easier for the user to place the food that has been cut in the former storage. This indirectly can maintain the hygiene and the quality of the food. Other than that, it also comes with a specific place to place the cutting equipment so that the probability for the cutting material to fall and hit the people around is low. Lastly, this product will be produced by using AM process so that it can reduce the labor costs. This is the reverse engineering and drawing view of this product. Reverse engineering is the process of redesign on the existing product in order to enhance and expand its functionality, improve its quality, and extend its useful life. The fundamental goal of reverse engineering for this product is to lower the product labor cost and make it competitive in the market. This design has been made by using CAD software, which is Autodesk Fusion 360. Then the file will be saved in the STL format and will be transferred to the AM machine. Okay, now I will explain about the machine specification. We have been discussed and choose to use the technique of material extrusion, fused deposition modeling or FDM to produce this product, where the material that has been selected as the filament as ABS material. This is the machine specification to build this product. For the back size, the dimension is about 200 mm at x-axis and 100 mm at both y and z-axis. Only one extruder is needed in order to produce this product. The layer height and extrusion width it has been used is 0.2 mm and 0.4 mm. Moreover, the sparse infill density is about 30% and the sparse infill pattern that has been selected is a gyroid. Lastly, for the travel speed or moving speed of the print head during the non-printing status is about 150 mm per second. Lastly, I will explain about the AM simulation. The orientation of the chopper board drawing has been drawn in the bottom plane or upside down. This is because the orientation of it is an important issue in order to reduce the material used in terms of support material. The former storage it has been drawn in a normal orientation. Next, the machining time for the chopper board is about 4 hours. It uses about 35.1 mm filament and contains with 175 layers. While for the former storage, the machining time is about 1 hour and 23 minutes only. The filament that used is about 20.1 mm and contains with the 100 layer. Now, I will show the AM simulation video for the chopper board and the former storage. Enjoy!
continue to the discussion.
My name is Nur Shafanina binti Azizul. Next, I will present about the discussion of the project. Firstly, is the difference between the old product and a new product, which is traditional chopping board and multifunctional chopping board. The material that often used for the old product is natural materials such as bamboo and wood, while the new product use a polymer such as ABS, HDPE, PP and PA, which is highly resistant compared to the new product material. Next, in terms of storage area to store the chopping board, the old product is easy to be stored because the shape and size is small and thin due to its single function. Unlike a new product, it requires a large space to be stored due to its size and shape that contain two parts, which is chopping board and a former storage. Then, the workspace to chop the food. The old product has a limited space and quite fibrous because it does not have a special container to store the chopped food. Compared to a new product, it has unlimited space to chop the food because it has a special space to store the chopped food. Moreover, the old product is less hygiene compared to the new product because the workspace is small and less organized. Besides, the old product is less safety because it does not have a storage to store the chopper equipment such as knives compared to the new product. Lastly, the manufacturing method used for the old product is traditional process, while require a lot of steps to produce a chopping board. For a new product, it only have a single process used, which is additive technique such as fuse deposition modeling. Then, continue to the bill of material. As I mentioned before, the FDM is a single process, so it only requires a filament as a material to manufacture the multifunctional chopping board. It only requires less than 1 kg of filament and 1.75 mm diameter to produce the multifunctional chopping board. The total price of filament is Rm82 ringgit and 90 cents to produce 3 multifunctional chopping board. Then continue to the cost analysis. The cost involved for this project is direct and indirect cost. The direct cost is the material cost, while the indirect costs are production overhead, labor cost, and machine overhead. The total cost involved for this project is Rm37,040 ringgit and 80 cents per year, while fixed cost involved is 36,020 ringgit. For variable cost involved is 16 ringgit and 60 cents per unit. The production cost for 1 unit multifunctional chopping board is Rm18 ringgit. The profit margin set for this 1 unit is 15%. So the profit gain is Rm2 ringgit and 70 cents. So we sold 1 unit at Rm20 ringgit 70 cents to cover up all the production costs and gain a profit at 4 ringgit and 10 cents. This all calculation is involved all the total cost. Lastly is economic analysis. In this project, we made eco-design web and product lifecycle. The function of eco-design web is performed to assess the environmental performance of product. It assesses different environment all areas, which are materials, the distribution, the use, the lifetime, and the end of product. The eco-design web work by comparing the 7 design areas with each other to identify better than or worse than output. Then, the product life cycle is used to assist in considering the environmental and social impact of the manufacturing process. It also a product life cycle period of a time between its introduction to market and its removal from the shelf.
This is our eco-design web and product life cycle. This filament material is a sustainable material because the expensive material can be reused again and again.
So, the conclusion is, from this project, the invention, features, and implementation provided after demonstration the new 3D model of chopping board as compared to typical chopping board, the invention is the following. First, the body of the chopping board is made up of pulley to prevent contamination in the air before cooking. The cutting board with pulley rolls along and it violently dragged outward to put the food ingredient into the storage drawer under the chopping board. Second, a safety lock is included in the innovation to prevent the chopping board from moving and hurting people while in operation. Next, the storage drawer beneath the cutting board features several plates for adjusting space dependent on the user's need. Then, magnet will link the chopping board's body with the auxiliary cooking equipment to simply connect the auxiliary cooking appliance to one side of the body to use it. When not in use, it can remove to conserve space. Then, when utilizing the auxiliary cooking equipment, food items will be pushed into the drawer under the chopping board to avoid food waste. And lastly, the body and auxiliary cooking appliance storage drawer have multiple small holes bottom to drain excess water from food materials, and the water pans under the drawers are designed to collect such water to prevent water for cleaning food materials from logging to drawers and negatively affecting food material sanitation. For recommendation of this project, I will recommend high density polyethylene for the multifunctional chopping board because it has high impact strength, low moisture absorption, excellent chemical and corrosion resistant, which is suitable for household, commercial food preparation, food packing and handling equipment. So for customers' benefit, it is stable environment for food preparation and package. So this is a figure shows high density polyethylene ultra durable chopping board.